Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from WX Risk, the commander of chaos, the colonel of confusion, captain catastrophe. Time to talk about weather again. And now that we finally moved into the winter pattern, well, the seasonal cool pattern anyway, and the hurricane season's come to an end, we'll be doing these reports now every Sunday evening, so you can count on that like clockwork from now on, all the way through till April. All right, just briefly, there's a picture of my smiling face from Richmond, Virginia, the Twitter page here, which does the regular weather, and of course the Facebook page. And this is, of course, how you can, if you want to reach me, there you go. So there you go. Okay. One thing I want to point out here, this is an interesting graph that somebody has posted on Twitter, and I'm using it. I'm taking, giving credit to the guy, but this is interesting, for the winter forecast here. Now, of course, NWS, NOAA Climate Prediction Center issued their climate prediction, their winter forecast, and as you know, officially, it's been a pretty warm forecast. Now, to show you the real impact of this, let's take a look at the current CPC Winter Outlook, which came out a couple of days ago, last week on the 17th of October. Here we can see that this is their December, January, February outlook. And they have an area of above normal precipitation across the Dakotas, Minnesota, Iowa, into New England, Northern Virginia, Pennsylvania, that sort of thing. And then the temperatures are generally near normal over the Midwest, and then slightly above normal in Virginia, Pennsylvania, down to Tennessee, Arkansas, and then more above normal over the West Coast and the Gulf Coast areas. And that's fine. If you take a look at the January, February, March forecast, again, notice here this is January, February, March. You'll see that it has right in here, January, February, March. Notice that it has a little area of colder temperatures, and that the normal area is expanded a little to the south and east. But one of the reasons I'm pointing this out is that if you're wondering whether or not the Climate Prediction Center ever has an area of below normal in the winter forecast, the answer is almost no. They're notoriously warm biased in everything they do. They do that because of the climate warming debate, the climate warming issue, and they don't use anything else except like the El Nino or La Nina outside of that. So almost every forecast they have is a warm bias to it. And what that means is that every time we've had a bad winter in the eastern United States, the Climate Prediction Center forecast, CPC, has missed it. So let's go back to this slide here. Now, this is the past 6 months. So let's take a look. This is the winter of 2013-14. Let me get a marker out here. Okay, you can see what it's forecasting. Near normal over the eastern U.S., and then warm temperatures over the Rockies, Southwest, West Coast. Now, this is the winter of 2013-14 here. As you can see, completely missed the cold. Completely missed it. That was a pretty cold winter too. They completely missed the whole thing. Absolute busted forecast. Okay, let's take a look at the next one here. 2012, 2013. Oops, let me get this here. 2013, and then you can see there, and look at the temperatures here. Now this one they got pretty close to being correct, so that was a good forecast. But the next one, 2011 and 2012, which was not a fairly mild and dry winter, they had cold temperatures here, as you can see, over the upper plains, and it was very warm everywhere. It's actually the exact opposite. So this also was kind of a busted forecast here. Okay. If you go to the bottom ones, 2010, 2011, they had the cold in the Pacific Northwest, the warm temperatures across the deep South. That was exactly wrong. Could not be more wrong. 2009, 2010, this was pure El Nino nonsense. That's all I did was regurgitate the El Nino crap, and they completely missed the forecast, as you can see here, 100% wrong. And then 2008, 2009 here, again, got the forecast 100% completely wrong. So the point is that when we've had the severe winters or moderate winters, the Climate Prediction Center forecast is almost invariably wrong. So I just wanted to point that out to you. I think this was a useful slide. All right, let's take a look. This is the Drought Monitor from October 15th. And obviously you can see the severity of the drought increasing here. The red dots, in case you didn't see them, that is, extreme drought here. And you can see all the red dots in Georgia and South Carolina, Central Texas as well. Now, after the rains we've been getting, I'm sure the new one on October 22nd will be significantly different. This is the Sunday evening radar. We can see the current storm now leaving New England, and then the next big system right in here. This is the next big developing system for the plains and the upper Midwest. Here's our Sunday evening weather map, and notice we have the two areas of low pressure, one here and one here. There's a coastal storm. This is several hours ago, so this is a fairly old map. But now what's happened is, of course, it's now pushed on in this direction. These two features are going to merge over here and stall. Now this one's going to be a rainstorm, not a snowstorm for the Dakotas. All right, let's take a look at the rainfall here and see how the things have worked out. Now, this image here is the current rainfall for the last 48 hours for the Mid-Atlantic region. So some of this, tomorrow I'll probably have better rain maps I can post here, but this is the border with Virginia here. Okay, so this is a Chesterfield County, you can see there in Richmond, and there's Washington D.C. See that? Okay, and there's Fredericksburg here, and this is the Delmarva, as you can see down this way, and there's a Roanoke out, Blacksburg, Roanoke out in this area. So I'm just going to give some bearings here. So the light blue, light yellow color, that's 3 to 4 inches right in here. You see that? And you can see that it's just the south and east of Richmond. There's Norfolk, so it's just in the eastern Virginia area got slammed. Also down here in the Virginia Piedmont and right along the Virginia border. Interestingly enough, we had 1 inch rains, 1 to 2 inch rains over much of the Shenandoah Valley, and of course 1 to 2 inch rains up in Washington D.C. So quite a bit of significant rain in these areas. If we take a look at a bigger scale, this is the same image, but now you can see from Georgia to New Jersey. So, and this was very good rain here, really good rain for the southeast area and this drought area. This was a really terrific event, no doubt about that. Okay, now if we go back and we take a look to the rain event we had in the middle of last week, again, the last Wednesday, this is the last 5 days. And again, let me give you your bearings here so you can see what's going on. This is the Virginia-North Carolina border, alrighty. And this here is Richmond right in this area here. And this is, let's see here, this is Washington, D.C.'s, and yeah, and right in here. So you can see that. So this is Lynchburg, there you go. And there's Roanoke here. And there's Charlottesville up in here. So again, there's Norfolk, Hampton Roads. Notice the dark yellow areas. That's 5-6 inch rain. See that in there? Very impressive in this area here, 5-6 inch rains. And large areas, again, 3 to 4 inches. All this yellow stuff here. That's pale inch. That's 2.5 to 3 inches. That's 3 inches in here. So very large area of rain over the last 5 days. And again, if we pull that out and take a look at it, we can see, again, Virginia, North Carolina, Eastern Maryland has done really well in the last 5 days with regard to the drought. Now let's take a look at the accuracy of the models here. This next slide, we can see the forecast for the rainfall. And this takes us up to Sunday night or early Monday morning. And this was from the 18th of October, which was Friday, I believe, yeah. And we can see some different things here. The this is the European model. And notice that the European model has these 2 surges of rain here and then again here. And then, but it also has significant rains of a 1/2 inch, 3/4 inch, fairly far up into the Shenandoah Valley, south of D.C., but definitely 1 inch rains around Richmond, and the main push is here. Now the NAM was a little more aggressive with it. It had 1 inch rains all the way into the Shenandoah Valley, as you can see up into here, and had 1 to 2 inch, 3 inch rains up to just to the south of Roanoke, and then widespread 1 to 3 inch rains in central and eastern Hampton Roads, Virginia into Hampton Roads, the Middle Peninsula, the Delmarva, that sort of thing. Notice that eastern North Carolina on the NAM was a little dry, and this is the GFS. Notice here the GFS is all the rain way to the south. It's got much less rain in the Shenandoah Valley, nothing in northern Virginia at all. And all the rain is concentrated 3 to 5 inch rains in northeast portions of North Carolina, southeast Virginia, Hampton Roads. That was, like I said, that was the Friday data, and then Friday night. So now this image here, this shows us for a Friday night, early Saturday morning, the 0Z European, and the 12Z Saturday morning NAM. And again, the model agreement here is really good. So once again, we're seeing that when you get the European and the NAM model together, that's a pretty good combination usually. Now the NAM could be a little, you can notice that it's got this really heavy area of 5-6 inch rains in here. And that probably did not verify, but it wasn't terribly far off. And the European was really good with his 2 to 4 inch rains in here, and you can see how good it was. But just to remind you, we go back to taking a look at there you go. So you can see it really picked up that 2 to 4 inch band here. The European did a very good job with that on Saturdays. 0Z Saturday run. Okay, so this was now the 12Z GFS. Notice it's a little further north than it was earlier. This was the previous run down in here. This is the previous run here. So notice again, if we look at the new stuff, 12Z GFS on Saturday, more rain in the Shenandoah Valley, no doubt about that. Not as much concentrated in Hampton Roads, but still significant rain. Also getting some quarter-inch rains up to DC, so, and in eastern Kentucky. A little further north, still way south than all the other models. Now this was the European model for Saturday afternoon. It actually came south. So you're thinking, okay, the rains aren't going to be that big a deal now. It looks like mostly North Carolina. So, if this was a winter storm, you'd be going, well, maybe not that much snow. If this is a snowstorm because the European came south. But one of the good things about this is the European now runs this 18Z model. And you can see what happens here. This is the 18Z Saturday afternoon NAM model, and it just went bonkers with the rain, constantly pushing it northward, driving 1 to 2 inch rains up the DC area, really good rains in the Shenandoah Valley. All in here you can see that 1 to 2 inch rains, and you can see this 2 to 5 inch band in here. Some areas 6 or 7 inches, isolated pockets. Now this was way overdone. Some of this is way overdone in here. I mean, you can see this is just not correct. It's just overdone. The NAM sometimes does that, so it's not be a big surprise, but you can clearly see that 5 inch rains. That did not happen, but it wasn't far off, and it did have the rains further north. The This was the 18Z GFS, and it was also coming further north a little bit, and here was the 18Z NAM. Yes, Saturday afternoon, and it now has, instead of coming south like it did here, you can see it definitely surged north again. So all in all, the models did a pretty good job. The GFS had a tendency of being too far south. The European fluctuated a little bit. The NAM was really good, but over amplified with the rains in some areas. All right, let's move on and take a look what's going on in the forecast here. This is the next slide, the next system here. This big giant low. This is the connected to this. That's that system there over the plain states. It coagulates. It emerges into one big giant low. And we can see it here for Monday night over central Minnesota. And the cold front, very clearly defined, kicking out from the intense low down this way. Now, this is all rain, not snow here. And then the low goes north of Minnesota by Tuesday afternoon, evening. And the front is now moving through Virginia and Pennsylvania, New York with moderate rain again. So another rain event coming here. Not nearly as big, but definitely a decent rain event. This is the upper air map. You can see what's going on here. Monster storm again over the central upper plains right there. Very powerful system here. We have a ridge on the west coast, moderate ridge, not much, and then we're getting some sort of high increasing anomaly here in Greenland and Canada that's beginning to build up. All right, as we go further out in time, this is now here for a Wednesday night, early Thursday morning, and you can see that the system over the plain states and the north of Great Lakes is now filled. It's become one big giant trough, which we can see. Let me get my marker out here. This is just one big trough here. Very, very pronounced. The southeast ridge is still there. We have this increasing amplitude here. The anomalies are building up in Greenland, and then a moderate ridge in this area. So we're getting some cold air getting into the U.S. here. Very pronounced, very nice as well. And that continues to be a good sign, a very active pattern here. And then from that, what happens is we have our next issue, which is the event for October 25, 26. So this is the GFS and the European. Now here we have two different solutions. So notice this is both valid October 25. So we're both dealing with the same time frame. Now the GFS, well, let me just call the marker up here. You can just see we have got this one big trough on the GFS. See this right here? Now the European splits this piece apart. The southern piece comes down here, and the northern piece is this way. So that causes a significant difference in the pattern. So the GFS moves this trough to the east coast and develops a significant rainstorm October 25, 26. The European has some rain, but it's not a big deal. Well, let me show you what this looks like. This is the GFS solution. And you can see here's the cold front on October 25. Right, there it is right there. the big cold high coming down. That's right, cold air coming in. Okay, there's the warm high off the east coast feeding the southeast wind, so you're getting a lot of rain developing over the drought areas again. And then what happens is the front moves through and it stalls along the east coast, and you get two waves of low pressure. This is October 26th, so you get a very big 2-day rain event: Virginia, Maryland, North Carolina, South Carolina, maybe even Georgia and eastern Maryland, which again, great news for drought smashing rains here, if that solution is correct. The problem is, like I said, the European does not agree. The European has the main low not on the coast going up into Chicago, Illinois, with some rain with the front. It is not dry. And you can see right here, there's the low, and then the warm front's like this. So again, it would be rain on Sunday the 27th, not the 26th. And also it's a 1-day rain event, not two. The problem is that if we look at the ensembles, we're not seeing any difference here. This is the GFS ensemble in the upper left. Notice, again, one big trough like this. Okay. Now the European's got a secondary piece of energy here, but it's not closed off. So that's a little more like the GFS model here. So this is uncertain yet. It's hard to say which solution is correct. I think the GFS is going to be correct on this. I think the European is hanging his energy back too much over the lower plain states. So that would imply a bigger rain event for Friday, October 25 and 26. All right, let's take a look at our teleconnections, our patterns here. Now this top one here is the Arctic Oscillation. Here's the AO. And notice that at the end of the month here, we begin to drop and goes negative, and generally runs slightly negative into early November. This here is the NAO, North American Oscillation, or the Greenland block, and notice that it starts running fairly strongly negative here for most of the end of the month into the first week of November. So that's encouraging. We want to see that. And then this is the EPO. This is the when the ridge goes from the west coast up into Alaska and potentially the North Pole and brings in the cold air. So when it goes negative like it does here, you see this is now negative. You can see it's very strongly negative. That allows the ridge to build up into Alaska and then pull the cold air, so you get a deeper trough and colder air coming southward. So that's a very good sign on the EPO. All right, let's take a look now, go week 2. And we can see here, this is the Sunday the 27th GFS and the European. Both models here now are in good agreement. You can see that we have this big trough here over the western U.S. right here. See that? And we're getting our nice ridge in the eastern Pacific, Gulf of Alaska. Both models have this. And we're getting to see a height anomaly develop here over Greenland, so that's encouraging as well. So this implies obviously a big system for the Rockies, the Plain States once again. Fairly mild temperatures for the East Coast at the beginning of the Halloween week here, but it's going to change. And then this here is, of course, 204 hours. We see the big anomaly over the Great Basin, the Rockies, California, Nevada, moving steadily eastward now. Notice, again, very strong anomalies developing here over Greenland. That's a nice sign to see. It's a nice 50-50 low. So this whole trough is going to eventually swing eastward. You'll see it. It'll do that in a minute. And then if we go beyond that, this here is 11 to 15 day. Well, yeah, we're getting to that time frame. Here's the GFS ensemble in the upper left. The bottom right is the European. Both models are showing that the system that was out here is now here. Okay, moving through the Plain States. We're getting a lot of strong blocking in Greenland. That's a very good sign. You want to see that. The ridge is beginning to push up through Alaska. You can see that a little bit. So this is a colder pattern. Notice also the ridge that was over here, that's now gone. So it is turning colder here after October. This is now, I guess, November 1st. And then beyond that, this is now 11 to 15 day. Actually almost a 14 to 21 days. So this takes us really to November 3rd to the 10th. The European model here, nice ridge on the west coast, and also strong some blocking here. Moderate sized trough like this is very nice. This is the CFS here on this side, and you can see again strong blocking anomalies over Greenland. Moderate sized trough here, a split in the jet stream, moderate ridge on the west coast, but the southern portion of the jet stream is coming in. And then it even looks even more impressive on this slide here, which takes us into I guess mid and late November. And what's important about this is that we have a split in the jet stream here. Well, actually, here's our negative NEO, so that's good to see. We have a ridge on the west coast, and then this split in the southern jet stream here. Now, it's too early to get excited about this, but this has got potential, if this were to verify, which is a big if. But, it's something to watch out for in the future. Okay, and one other thing I want to add here is taking a look at the Siberian snowfall. So let's take a look at the Siberian snow cover and see what's going on. Now, one of the reasons why we look at the Siberian snow cover in the month of October is because there is some connection with how and when the Arctic oscillation goes negative and the amount of blocking that develops, especially the second half of the winter, January, February, even into March, over the Arctic regions. So the problem is that it's not always a powerful influence. Sometimes if you have a raging El Nino or La Nina, it can counter the influence of the Siberian snow cover. And sometimes if the Siberian snow cover is just average, well, it doesn't have much impact on anything. So, but it is something to watch for in the month of October, and that's why we watch it. So on this slide here, it explains what happens. Now, the image on the left-hand side shows us what happens when we have a low snow cover years in Siberia during the month of October, and high snow cover years when you're on the right-hand side. So what happens is the snow cover expands when you have a lot of snow. It induces surface cooling and strengthens the Siberian high in November. The tropospheric jet amplifies, and it sends energy into the Arctic region. That causes the polar vortex to weaken and split into pieces, and then you end up getting blocking patterns and negative NEOs in January and February. Now, it does not happen, as you can see here, in the low snow cover years in October. So that's why we take a look to see how it ends up impacting the pattern. Now, this is the latest chart here from Judah Cohen over at AER, and you can see that it has, we're looking at the black dot, and that's the one we're looking at right now. So if we focus on the black dot here, again, right here, there it is. Let me go mark up so you can see it. Right there, that's the feature of what we're looking for. So as you can see, it got off to a very big start early, then it reached this plateau here. Now it started zooming up again. So we'll see how now we can look at the models to see where the snow cover is going and how it might work and how it might impact things. Now, this is an example of when the snow cover forecast kind of worked and kind of did not. So this was the AER forecast that they produced for December, January, February, this past winter. And then as you can see on the right hand side, this was the actual temperature anomalies for the winter. So it really did not work out. As you can see, the coldest anomalies, you can see a lot of below normal temperatures here, but they had the below normal temperatures here. So that did not work out. That was not particularly well done. They were pretty warm in the southeastern states, the eastern U.S., that was warm. So it wasn't a great forecast. But this one here, you can see this is from winter 2017-18. They had a lot of cold. As you can stretching across the Dakotas into the Great Lakes and down to the Mid-Atlantic region. The cold was mostly here. It didn't get into the Mid-Atlantic region, but it wasn't far off. And notice that they had the warm temperatures in the Southwest and in the Rockies, and that's exactly right. So that was a pretty good forecast. All right. Now this is the current snow cover here as of October 21st, 20th, and you can see pretty good snow cover amounts here. You can look at the color scale at the bottom to see where it is. This is the centimeters. And the thing to do that we'll look forward to is this is 60 degrees longitude right here. So the thing that makes a difference in the month of October is how much snow comes south of 60 degrees longitude. That's the big key. So you can see there's quite a bit of significant snow cover here. Now notice there's a gap right in here, not much snow going on. And if we look at the patterns, and this is now for November 1st, we can see a huge increase in the snow cover over western Siberia and a major increase in the depth of the snow cover all of central Siberia as well. It's a very impressive looking pattern. So this is clearly showing there's going to be an explosion of snow in Siberia in the last 10 days. And we can see why if we look at the upper air maps here. Very easy to understand. This is the 22nd of October. This year is the 24th. And we have this big shortwave coming in this way. A little bit of a ridge here. This is why the snow had stopped. But this big system coming in drops down into Mongolia. And here we get these waves of energy coming in this way. Very pronounced snowmaking pattern. This is October 26th and October 27th. Huge upper low. This is really significant right here in central Siberia, sending these bombs of energy. One piece of short event here, another one here. Each one of these are snowmaking events, low pressure areas. Another one there, another one here. And then if we look at the pattern continuing out, this is now October 29th, and you can see this huge upper low over Siberia and Mongolia, very producing a tremendous snowstorm here to close out the month. The GFS and the European are in very good agreement about that to close out the month, which should add a lot of snow cover the last 3 or 4 days before the month comes to an end. Anyway, there's our this week in weather. This is meteorologist DT from Weather Risk. I'll see you on the Facebook page and on the Twitter page.